Okay, good evening, everyone. We're going to go on a little journey. So close your eyes and just imagine the morning has broken, your alarm strikes, you wake up full of anxiety and excitement. The big day has arrived. You go through your morning routine, you get into your car, and you head to the office. All the preparations are being made for you, but you've also got to get yourself ready. And so you get yourself ready, and now you're seated. And you have this beautiful vehicle right beneath you. You can feel the pressure of gravity on you as you lay back in your seat. And you take a second to think about the amazing journey that you and your colleagues are about to embark on. The moment arrives. 5, 4, 3, 2, 1. Blast off. You can feel everything around you shaking. You can feel the pressure of the G's pushing you back into your seat as you ascend through the atmosphere. You look around and you see everybody laser focused. This is the moment you've been waiting for. Now, as you break through the atmosphere and you see slowly the Earth disappearing, you realize that this is going to be your home for the next 6 months. So you got to learn to love it. Now, you spent 6 months with your colleagues exploring this small environment, learning how to work together, live together, and not get pissed off with each other. And then one day you look out the window and you see something magnificent. And it's starting to dawn on you what you're going to be doing. And as the days pass by, it gets closer and closer. And you start seeing this beautiful red orb right ahead of you. Home is calling. And now, the most important part of this entire journey, you strike the atmosphere and you feel everything shaking again. One small mistake, and you could all be vaporized. This is the most harrowing experience you've had in your life. But fortunately, you touch down safely. Everyone looks around at each other. You can't even fathom the magnitude of what's just happened. So, you don the suit, you open the door, and for the very first time, you step out onto the surface. This arid, inhospitable surface, that's now your new home. Welcome to Mars. My name's Kartik Kumar. I'm one of the analog astronauts at the Austrian Space Forum, which is a citizen science, volunteer, not-for-profit organization based in Innsbruck in Austria. I actually wear a lot of different space hats. I've dreamt of space for as long as I can remember. I'm also a PhD candidate in the Netherlands working on my thesis on astronomy. And I'm also the founder of a space startup currently being incubated by the European Space Agency. So I live, breathe, and eat space. And yet there's something beyond all of that that compels me towards Mars. And it's a story that I'd like to share with you. But before we do that, I think it's important to get a few facts straight, so you get a sort of a sense of an order of magnitude of what it is that we're talking about. So what's the average distance to Mars from Earth? Does anybody have an idea? So it's close to the 300 million. It's about 225 million kilometers, or as is measured by astronomers and planetary scientists in astronomical units, about 1.5 astronomical units. An astronomical unit, which is approximately 150 million kilometers, is the average distance between the sun and the Earth. What's the average surface temperature? Well, it's actually pretty cold. The average surface temperature is about minus 70 degrees Celsius. It can go as high as 20 degrees and as low as minus 110 degrees Celsius. But so you can already get a feel for how inhospitable this environment actually is. And what's the average surface pressure? Well, it's significantly different from what we experience here on Earth. It's only about 10 millibars, or even less than that in certain places on Mars. And so you have a completely different environment, completely different atmosphere to deal with as well. But what's more is that it's not the atmosphere that you're familiar with. The major constituent, about 96% of Mars's atmosphere, is carbon dioxide. Then you've got about a couple of percent each of nitrogen and argon, and everything else is pretty much trace elements. This is not what we're familiar with here on Earth. And so it's something we're going to have to contend with if we're going to sustainably make it to Mars and live there. There's some interesting comparisons between Earth and Mars. One of the unique things is today, as it stands, the obliquity, which is the tilt of both Earth and Mars, is approximately the same. This hasn't always been the case, and this won't always be the case. So we're kind of in this statistical anomaly in which both obliquities are approximately the same. The other interesting curiosity is a Martian day is more or less an Earth day. It's about 40 minutes longer, which actually leads to some interesting effects on our bioclocks. And as you can see here, the other very prominent difference is the fact that Mars is significantly smaller. In fact, it's small enough that it's a totally different gravity environment for us to be subject to. And the lower gravity has a significant impact on how we maneuver on the surface, how we do operations, and how we live on the surface. So this needs to be taken into account as well, not just from the perspective of habitats, but also the effect on the human body. And Mars itself is actually a system. So Mars is not on its own. What you see here are Mars's moons. Mars actually has two moons, Phobos and Deimos. Fear and terror. You kind of get a picture from this, from the naming of how people for a long time thought about Mars. A lot of mythology looks at Mars because of this redness as being this place of a lot of fire and war. And the story of Phobos and Deimos is really interesting. It's something that puzzles planetary scientists till today. The prevailing idea is that they're both captured objects, captured asteroids. But you see, for instance, in the case of Phobos, there's this major puncture on the side. And this tells a very important story about activity in the solar system and how solar system bodies formed. So it's important when you look at Mars to treat it as a system. And when you look closer at Mars, it's not just this boring red orb. It turns out to be a fascinating place. This image, which is a false color image showing altitude basically on Mars, taken from satellite imagery, shows you a number of really interesting features. One of the biggest things that will strike you is the difference between the northern hemisphere and the southern hemisphere. This is a dichotomy that we're still trying to figure out. Why is the northern hemisphere so much lower than the southern hemisphere? When here on Earth, because of plate tectonics and other processes, you have low areas and high areas kind of distributed across the planet. Now, there's tons and tons of stuff that you can find on Mars, and the more you look, the more fascinating it is. In fact, I hope one day somebody will write, and I'm sure somebody will soon write, the tourist guide to Mars. Because whoever goes out there is going to want to need it. So I'm going to walk you through a couple of interesting features that I think tell a story of how rich a celestial body Mars actually is. This pimple, for instance, is one of the most important features in the entire solar system. Does anybody know what it is? Do you want to shout it out? Right, and it's a specific volcano. It's Olympus Mons. It's part of what's known as the Tharsis Complex. And what makes this volcano so special is it's the highest volcano that's been discovered in the entire solar system. In fact, it's 3 times the height of Everest. Now, what makes this place really fascinating is that it extends over a vast area. And one of the things that I really enjoy about kind of these stories is if you understand a little bit about what goes on Mars, you'll realize that there's some really interesting features that you'd kind of be experiencing if you were on top of the summit of Olympus Mons. For instance, because the atmosphere is so thin, meteorites that strike the atmosphere, they only burn up pretty low in the atmosphere. So if you've ever seen shooting stars here on Earth, where do you look? I hope you're looking up, right? So if you were on top of Olympus Mons, the crazy thing is, you'd be looking down to see shooting stars. And to me, that's just a fascinating idea. It sort of screws with my head to realize that there is a place for where the experience is just so different from what we have here on Earth. Another very compelling feature is Valles Marineris. Valles Marineris is a magnificent place. It's the longest and widest trench in the entire solar system. It's thousands of kilometers long, hundreds of kilometers wide, and many kilometers deep. And it's a fascinating feature because it tells a really interesting story about Mars itself, and one that we're still investigating. From a tourist point of view, one of the things that I find so compelling about this is if you were to bungee jump off of the edge of Valles Marineris, you would be coasting for minutes before you hit the bottom because of the low gravity. So you'd get this beautiful, long kind of fall as you're exploring the trench. Something I hope someone will get to do someday. And one of the other things I wanted to kind of point to is Mars is a living, breathing planet. A lot of people think, okay, Mars is great, you have these features, but there's nothing going on. And the more we look, the more we realize this is not true. This is one of my favorite features. It's called Arbortolus. Does anybody have an idea of what's going on here? So what this would remind you of, if you were to look closer, is something like a waterfall here on Earth, right? But we haven't discovered these kinds of massive waterfalls on Mars. But you do see something that looks like the action of something flowing. And it turns out to be sand, indeed. And in fact, if you look closely at the base of this crater, you will see ripples and all of these kind of very dynamical features. At this scale, Mars really is a living, breathing planet. And one of the most interesting things for me is how far we've come as a species to be able to explore a place like this. This is one of our ambassadors out there on the planet, the Curiosity rover. A fabulous feat of engineering, doing fantastic science on the surface. But it's more than that. It's a representative of each and every one of us out there in the solar system. And when you look at it like that, you realize that an object like this, like Curiosity, really is a way for us to extend our reach into the solar system. Our eyes and ears basically allowing us to understand what's going on out there. And in the future, when the first people walk on Mars, this is going to happen together. Robots and people together will help us to understand the majesty and beauty of the red planet. This is probably hands down my favorite image of Mars or from Mars. This was taken by one of the Mars exploration rovers. There were two launched by NASA, Opportunity and Spirit, and both of them came equipped with cameras. So this is an actual image taken from the surface, looking up in the night sky. And what do you see when you look closely? You see our home. You see all 7 billion of us on this small speck in the cosmos. And I think when you look at this, it really gives me the impression that we have a lot more work to do to understand our place in the solar system and the universe at large. So I hope this has given you a little bit of a picture of why Mars and space exploration in general is so compelling. I think you can come up with a lot of reasons, whether it's economic in nature, whether it's societal, cultural. But deep down, I think even if you strip all of that away, the journey to Mars really is about our compulsion to explore and to understand the universe around us. So I'm going to now kind of step into a little bit more of an operational discussion. Let's say, for argument's sake, we all agree that we need to go to Mars. How are we going to do that? Turns out to be much more complicated than you would think. You know, people think, okay, we've gone to the moon, so what's Mars, right? You just gas it up a little bit more and you're at Mars. And it turns out that there's a lot of challenges still to be solved. This is actually an image of 2 Apollo astronauts. And they're doing something really curious here. You see them actually in their jeans, somewhere on Earth, standing around with some gear, picking up samples. And one of the things that's not really understood is that when you go on a mission to the International Space Station or to the moon and in the future to Mars and elsewhere, practice really makes perfect. Operational excellence is the most important thing in all of this, especially when you have human lives at stake. And so the Apollo astronauts practiced and practiced and practiced. And here they're basically mimicking the kinds of operations that they would do on the moon, really to familiarize themselves with equipment, understand procedures, and understand where things can go wrong. At this point, they were still analog astronauts, essentially preparing themselves for this future challenging journey into deep space. And so that's what I do. As part of the Austrian Space Forum, we do these analog missions in different places on Earth to try to replicate the circumstances that we expect to occur on Mars to help us really to achieve the level of operational excellence necessary to make a mission like this possible. This really requires a team. Here you see a small selection of the organization. You see my colleague Inigo in our spacesuit simulator. But the organization is much larger than this. It spans hundreds of people. And it really takes that extent to even run a mission, a mock mission here on Earth well. Future missions to Mars are going to require thousands and thousands of people. And so if I can leave you with one message today, is that there's not just room for everybody, there's a need for people to step up to the plate and contribute to this journey. So I went through the selection process. There was a call at the end of 2014 from the Austrian Space Forum looking for the next generation of analog astronauts. And I happened to come across the fact that the Austrian Space Forum was looking for analog astronauts at some small space conference that I was attending. And so I heard this short talk, and I thought to myself, well, chances of me actually going to space, probably pretty remote. I don't know. Maybe there's a ticket waiting for me around the corner, but the way things are, it's probably unlikely in my lifetime. And yet, some part of me has always yearned for that experience, but also the ability to contribute to society that way. So this seemed like the perfect way to get my hands dirty and really contribute something towards this journey to Mars. So I applied, and there were over 100 people from across Europe who applied for this program. We were whittled down through a battery of tests to figure out basically who's kind of ready to take on this challenge based on what the Austrian Space Forum actually does. So there was a very important physical component. Now, one of the misnomers is that astronauts are tip-top athletes that, would be able to run the 100 meters in less than 9 seconds and, jump 3 meters in the air. That's actually not true. Astronauts are healthy. Astronauts understand good diets. They also understand the impact of choices on their own health and the impact of their health on the success of missions. So they're generally healthy people. But as with most other facets, if you look at astronauts, you just see that they're above average to excellent in everything. So they have very few weak spots. And they're always working to better themselves. But they are, to a large extent, generalists, right? So the Austrian Space Forum in this process was also looking for generalists. So there was an element of physicality in this, so to have physical fitness. But because what we're doing is actually, and I'll show you some pictures of where we do these kinds of missions, there is an element of danger as well. So you need to be able to be ready to, even here on Earth, when things go wrong, respond to emergency situations. So we had first aid training, understanding how to put out fires, electrical fires, all kinds of different fires, understanding how to deal with medical situations in the field. So there was a lot of training and preparation that went into figuring out how to do something like this successfully. And then, of course, as an astronaut, you have to understand the technical aspects of a mission like this and also understand what the mission purpose is. What is your job out there? Because as an astronaut, your job really is to represent the wishes and the desires and the ambitions of the people who are backing the mission. And for a mission to Mars, that's virtually everybody. And so I went through the selection process, and I ended up being selected along with 4 other colleagues. And then we went into this rigorous training to actually understand how to conduct a mission like this in the field successfully. And a field mission actually is composed of 2 planets. We have operations happening on Mars, which is out in the field, but we also have operations happening back on Earth, because a mission to Mars is not going to just be about the dozen people or the half a dozen people that head to the red planet. There's a lot of work that has to be done here on Earth to make a mission like that turn out to be successful. In fact, there are going to be hundreds, if not thousands, of people here on Earth working towards the success of a mission like this. And we know this from missions to the moon, but also operations for the International Space Station. So we went into this rigorous training, and essentially at that point we were kind of ready to embark on this journey in the field. So I'm going to tell you a little bit about what it means to be on a field team like this and be involved in an analog mission, and what an analog astronaut actually really does. One of the most interesting parts of this is we have these 2 spacesuit simulators that have been used in the field. There's now a new generation of these spacesuits being developed, and they're essentially self-sufficient spacecraft. So they have an onboard computer, thermal control, a power subsystem, structure, all kinds of stuff to make sure that the astronaut who's wearing the suit is safe at all times and able to operate in the field to conduct the mission. In fact, these suits are so complex that every day what we do is 2 of the crew members who are analog astronauts are assigned to the suits. And because of the complexity of these systems, it takes anywhere from 2.5 to 3 hours to get the suit up and running and donned on the astronauts. Once this has happened, we finally enter the field and we conduct these extravehicular activities. And every day is basically about heading into the field and conducting the experiments that have been planned by the flight planning team back on Earth. They've uploaded the information to Mars, and then basically our role is to operationalize that plan in the field. Now, the spacesuit simulator itself is a really interesting thing. So the AUDA spacesuit simulator in particular weighs about 50 kilos, and an EVA lasts from anywhere from 4 to 6 hours. So there's a lot of physical endurance required, but there's also a lot of complexity in a suit like this. So you could think of hyper-complex systems and code and all kinds of things running on a spacesuit like this. And what it turns out is if you don't test it in the field, you don't battle test it, just as you probably experienced with your own code, your own apps, your programs, the failure modes for a system like this are, in some sense, unbounded. And so one of the exercises we're doing in the field when we're doing these daily operations is to figure out what all the failure modes are. And you have some that are very straightforward failure modes, and others that are hyper-complex, where you have a cascade of events leading to some sort of failure in the system. And this is where operations matter. The more you do this in the field, the more you understand all the complex and the simple failure modes for a system like this. So I'm going to focus the last part of the talk on an example mission. This was a mission that I was involved in last year in February. It was in the Dhofar Desert in Oman, and we essentially spent a whole month isolated in the middle of the desert. So the Amity 18 mission was situated in the southern part of Oman, a number of hours away from Salalah, basically in the middle of nowhere. And this was base camp. This was a picture taken by a drone of the actual setup, and it was a fully functioning mini civilization going on in the middle of the desert in Oman. The other thing is that these were temporary structures. So we arrived there and there was nothing there, and this was established. And soon after we left, this was all removed, and the sands basically reclaimed this land that we had been living off of. And when you're that close to the land in this sort of harsh, evolving environment, you realize how fragile human life actually is. One day you can be living on the surface, and the next day nature doesn't care. It will reclaim it. So it was a very tangible way to feel what the experience is going to be like on Mars, which is going to be many orders of magnitude more than this, of landing somewhere where no one has been before and setting up camp. And so basically what we did every day is we had a crew of about a dozen people out on the surface of Mars, supported by about 100 people back on Earth in Innsbruck in the Mission Support Center. And every day, 2 analog astronauts were assigned to the suits, and they went out on quad bikes, in most cases, to conduct these extravehicular activities. So what were these EVAs? Well, we had a series of science experiments that had been proposed that we went out to conduct on the surface. These range from looking for biosignatures on the surface, to detection of water, to understanding the geomorphology, to doing human experiments, human factors, and understanding human-machine interface. So there were a whole variety of experiments that we conducted on a daily basis during the course of this 1 month. This is an example of one of the experiments. This is a georadar. And what this does is it basically sends a radar pulse into the ground, and based on the composition of the layers below, you get a certain reflectance pattern. So you can start detecting what's subsurface. Now, when we're on Mars, why will we want to do this? Well, understanding the subsurface structure will tell us a little bit about how Mars is today, but also give us a signature of how it's evolved, and more specifically, tell us whether it's true that there are subsurface reservoirs of water or ice, right? And these are resources that could be very essential for us on the surface of Mars. And we also did a lot of, I would say, more advanced experiments, testing out new technologies, new ideas, and how these could contribute to a future mission to Mars. This is my colleague, Michael, who was basically in charge of the 3D printing experiment. And in this experiment, what we simulated was the failure of equipment on the surface. So we had a whole bunch of tools and equipment. We simulated failure in these equipment, a breakage, for instance. And then based on this breakage, this was reported back to the Mission Support Center, and the team behind this experiment essentially designed a CAD model that would basically replace this tool or enhance the tool or fix the tool, uploaded it back to Mars. We printed it there, and then we went out into the field and actually conducted the experiment and continued the experiment on the basis of this fix. Now, there's a lot to say for introducing technologies like this to bring self-sufficiency and autonomy to crews on the surface of Mars. So the interesting thing about an endeavor like this is you have very low-techy kind of problems to solve, but also a room to explore what the application is of very high-tech kind of stuff. And the suit itself is something that's evolving. I almost call it sort of a living, breathing being in itself. When you're inside the suit, it's kind of speaking to you. It's telling you a little bit about what it's able to do and what it's not able to do. And as the human operator inside the suit, you're very dependent on the suit for your safety and for your ability to perform what you need to in the field. So you're constantly iterating, collecting data, trying to understand how to deal with various issues and all that, and enhance the suit. In this case, my colleagues were working on the heads-up display. So we have a heads-up display inside the helmet that helps the analog astronauts essentially reporting, for instance, sensor data from inside the suit. We have a map that helps us to navigate and traverse on the surface, and also standard operating procedures that can be displayed. So there's a lot of these kinds of practical solutions that are needed to help astronauts and crews essentially be autonomous on the surface of Mars. And at the end of every day, we had a debriefing. So this is all about learning and understanding how to adapt to circumstances and situations. This is a picture taken during one of the debriefing meetings on Mars. This also happens on Earth, because we're also in communication with Earth during the mission. But the interesting thing is, because of the distance that I mentioned before, there's a delay in the signal. The delay that we simulate is on the order of 10 minutes one way. That means you can't just pick up the phone and talk to somebody. So you have to deal also with asynchronous messaging, and how do you develop the ability to predict what the other side's going to say, because sometimes you have to respond to something in real time and you can't wait for the 20-minute round trip for the message. So you start developing this sort of sixth sense for what's happening on the other side, whether it's when you're on Mars to understand what's going on Earth or vice versa. So these debriefing meetings are really important to try to assimilate all of that knowledge that's being gained during a day on Mars and on Earth. This is a picture taken from the flight control team on Earth. So you see here the flight directors on the left of the picture, and you see all the different workstations and the different people who are kind of following and tracking and supporting the mission. As I said, this happens with this 10-minute one-way delay, which adds a lot of complexity to the system and forces you to have to think about how to anticipate situations that are happening on both sides. And the very important message from this is that a mission like this happens on 2 planets. So really what's happening on Earth is just as important and complex as what's going on Mars. So I'm going to end with a last bit of information and sort of a call to action. Our next mission is going to be at the end of next year, in the October-November timeframe, in the Negev Desert in Israel. So this is also a very, very good test bed because there's a lot of geomorphological features in this area that are very interesting as an analog for Mars. But we're also upping the fidelity of the mission on the surface to understand even better how to tackle some of the core challenges that stand between us and actually stepping foot on the red planet. In fact, I have a little announcement. So there is an announcement of opportunity at the moment. This is for the Junior Researchers Program. So if you know anybody that's between the ages of 15 to 25 that has an interesting idea, an experiment that they'd want to conduct on the surface of Mars, there's an opportunity to propose an experiment. Unfortunately, the main announcement of opportunity just elapsed. So the selection process for, let's say, the non-junior researchers is going on at the moment, and mid-next month, there's going to be the public announcement of which experiments have been selected. But there's still an opportunity for junior researchers, so between the ages of 15 and 25, to propose an experiment. So if you're either in this age bracket yourself or you know somebody who has a super cool idea of something to test or to experiment on the surface of Mars, just have a look on the website of the Austrian Space Forum. In fact, there's a page already up for the Amity 20 mission, that's the name of this new mission, where you'll find all of the information about what's going on and also how you can contribute to the mission if you're interested. Similarly, there are multiple roles within the organization that have to be fulfilled. And one of the coolest things is you can actually be involved in the flight control room or the flight planning team. There's always need for intelligent, enthusiastic people. So there's this program, the Analog Mission Basic Training, that you can participate in. The dates have just been announced from the 28th to through the 30th of June in Innsbruck. And this is something that you can find on the website as well, more information on how to apply and get into this program. If you're interested in kind of leveling up on your understanding of how space missions are conducted, but also potentially being involved in the Amity 20 mission. And the last piece of information that's probably relevant for you here is that there is an extensive science data archive that's been built up over the more than a dozen missions that have been conducted by the Austrian Space Forum. We collect telemetry data, human factor data, team data, all kinds of data that's stored inside this archive. And there's a lot of fantastic stuff that can be done with that data. I think we've not really even fully scratched the surface of what you can do with that data. So you can get access to this data through the website if you want. If you have some cool idea for a visualization or some analysis that you want to do on the data or some app you want to build or something, this data is available. And through the website, you can contact the science data officer who can provide you with access to the data. So to end with, I wanted to end on a note that is personally relevant to me. A mission to Mars for humans is really, really tough and challenging, and it's going to come with a lot of pressures and a lot of challenges and issues. But one of the things that really compels me about this is it's also fun. It strikes at the central chord of why we, as a human species, explore, why we have this need to explore and to understand. In fact, when I give this talk to kids in primary school, and I ask them who wants to go to Mars, you pretty much see every single hand go up. At that age, kids are still dreaming, right? And I think some element of us, even as we become adults, and you lose maybe that perspective of how much a dream can matter, it's still in there somewhere. So if you're not compelled to jump on this journey or any other journey of exploration, I would suggest take some time to think about what it is that really motivates you. And I think when you find that thing that really sparks the idea of fun and creativity, that's when you have an opportunity to create maximal impact. And so what really drives me about this is it's very unlikely that I'm going to go to Mars. I'm sorry to say it, I don't think there's a great chance of any of you walking on Mars, although you might prove me wrong. But at the Austrian Space Forum, one of the things that's a firm belief within the organization is that the first person who's going to step foot on the red planet is already born. Somewhere in some kindergarten class, could be in a school here in Lisbon, or in Tokyo, or in Mumbai, or in Washington, D.C., there is a kid today who is going to step foot on the red planet. And that, to me, is the most compelling reason why I take my time and effort towards this journey. It's because it's our shared journey into the cosmos, and it's a way to enable the next generation to literally shoot for the stars. So my name's Kartik. I'm an analog astronaut at the Austrian Space Forum, and I'm a Mars pioneer. What does that mean? Well, it really just means that I've decided that this is my journey as well. And all of you can be Mars pioneers as well. There's a need for lots and lots of people. There's a need for technical people, but there's a strong need for non-technical people as well. Designers, lawyers, doctors, artists. This is our shared journey. And so if I can leave you with any message, it's this. There is an opportunity in front of us right now. Let's grab it and shoot for the stars. Thank you. So I don't know how we're doing on time and if there's time for questions. Go ahead.
Do you do any exercise to simulate to compensate for the gravity difference?
So the question is whether we do any simulations to compensate for the gravity difference. It's one of the most difficult things here on Earth. We don't really have a switch for this. You see some groups who do this kind of research, they do, for instance, they use neutral buoyancy underwater as a way to compensate for the effects of gravity, right? This is very expensive, requires a lot of infrastructure to be able to achieve something like this. So space agencies, for instance, are able to do this. In our case, the best example, tangible example I can give you relates to the effect of a spacesuit on the body. So one of the things that we do is, and you don't see that from the outer layers of the spacesuit, on the surface of Mars, not just because of gravity, but also because of the thin atmosphere, the suits have to be pressurized, right? Because we have to breathe oxygen at the end of the day. And when you pressurize suits, what happens is, it's like with a balloon. When you blow up a balloon and you press somewhere, you have this effect of the balloon basically expanding in a different direction, right? So when you're inside a pressurized suit, you have the same feeling. And what that does is when you're folding your arms, for instance, you have resistance. So this force is really important to model. And one of the things that's been developed at the Austrian Space Forum that's pretty unique is this exoskeleton that sits outside of the outer layer that compensates for this hysteresis, for the force due to pressurization, but also kind of taking into account the lower gravity and how you would maneuver inside a suit like this. Beyond that, you can do things like zero gravity flights and things like that to look at how your experiments respond or how people respond, or basically extrapolate from research. We have a lot of people who've now been on, well, relatively a lot of people who've been on the International Space Station compared to before it existed. Still a small fraction of people that hopefully will make it to space. So we have a lot of published literature on the effects of low gravity environments on the human body. So there's an open question of what long duration effects will be of partial gravity. And yeah, there's a lot of work that still has to be done in this area. I hope that kind of answers your question.
Yeah. I've seen the National Geographic Mars series, and I think maybe you've seen it too. And my question is, I want to ask you how accurate you think the TV series are in fact.
Yeah, I mean, it's a good question. It's you can make the same, you can ask the same question about a movie like Gravity or even The Martian, right? I think it's as with any of these things. There's a level of like over dramatization of things, and then there's things that are just spot on. From the experience that I've had, at least, I think the essence of it being this very messy, kind of complex environment in which you have to deal with technologies that fail, systems that fail, but also people that kind of get in the way, and irritations, and how do you deal with being with another person in this closed, confined space for such a long time. But also, what do you do on the surface when things don't go to plan, and how do you deal with medical emergencies? And I think that's pretty close to what the challenges are that we have to be able to address as well. So I think the National Geographic series, for instance, is a good portrayal of where we are today, but also what stands between us and successful completion of a mission like that. And there are a myriad of reasons that a mission will go wrong. We're not going to be able to cover all our bases. There's just a level of complexity that we probably can't mask or take care of. So it's all about risk mitigation and having contingency plans and understanding systems and understanding systems of systems. I think the Mars series does a good job of kind of portraying this level of complexity for future human missions to Mars.
Hi. So realistically, if we had an extinction event right now, how could we, or when could we establish a colony potentially on Mars?
Yeah, so there's some things that money buys and some things that it doesn't. So funding is definitely an issue. If we throw more money at this, it goes faster. It's just as simple as that. There's been a lot of experiments with this idea of where is this money going to come from. It's one of the main things that's going on in the industry at the moment, this whole push towards commercialization and opening up of the industry. It's also the entire reason my startup exists as well, is that focus on commercialization of space. So I think we're getting there to the point at which funding streams start becoming available to accelerate something like this. Of course, in a moment of emergency, we hope that governments kind of come together, the UN kind of puts some framework into place. We do have technologies to address a lot of the problems, but I think that technology is not the only issue, and that's a very important thing to understand. In all of this stuff, for me, the most hyper-complex part of a human mission to Mars is the first word, the human. We don't really know what happens when you isolate a small group of people at an infinite distance away, what it does to them psychologically, what it does in terms of their ability to respond to threats, deal with medical emergencies. So I think if it's simply about depositing DNA somewhere, we could do that. If you're talking about actually having living, breathing people be happy and be able to operate on the surface, a lot more work has to be done, and we have to bring more people into this fold and have, as I said, technology speak to all these different disciplines as well, because you're not going to solve it with just technology. At least that's my experience of it. I think we've run out of questions, or any other? All right, well, I'm going to be here the rest of the evening as well, so if you have any questions about this, about space in general, about what's going on in terms of startups in space and things like that, just catch me, and I'd be happy to have a chat.